Right. Here's one for the geometry kids. And also a review for the 7th graders. Yeah, dog. 7th grade and 10th grade. Same math. A lot harder for the geometry kids, though. You believe it, puppy? Thinking about it. Alright, so we looked at scale models, how it relates to scale factor, and we're just going to go over these last 3 questions since they were giving people trouble. I did not anticipate it would give us as much trouble as it did, but such is life. So if we go back, if we do number 5 here, so our guy's making a 139 centimeter long scale of the Parthenon for history class. The actual length is 69.5 meters. So if we want scale, it means it just wants a ratio, like what we had on our graph. Or not our graph, our map. Instead of 0.5 inches 20 miles, it's some number of centimeters to some number of meters. We can write it out as 139 centimeters to 69.5 meters, and then we just simplify that. So if we put on our calculator 139 divided by 69.5, that's 2 to 1. So we say 139 centimeters, 69.5 meters simplifies to 2 centimeters, 1 meter. And that's our scale. Okay, scale is just a ratio used in units. Then it wants to know how many times, and I think I got this one wrong because this worded kind of weird, how many times as long as the actual Parthenon is the model. So it wants to know how is the model related to the Parthenon. Okay, so if we want this number, how many times as long, it wants the actual scale factor. Fancy way of saying that. So if we want scale factor, we just want the number we can multiply, which means we can't have centimeters compared to meters. No, we can't, dog. They have to be the same. So we can convert one to the other. And so we talked about in class, it's easier to convert meters to centimeters than centimeters to meters because like 2 centimeters is 0.02 meters. And we probably don't want to deal with decimals. So we can say 1 meter is equivalent to, that's okay. 1 meter is equivalent to 100 centimeters. Okay, so all we did is we just converted 1 meter, 100 centimeters. 2 centimeters, that's already in centimeters. I don't have to change it at all. Okay? And then if I rewrite this is a ratio. You can write a ratio with a colon between. You can also write it as a fraction. Okay? And as you know, anything divided by itself is 1. So if we have centimeters divided by centimeters, then these just cancel out. And so our scale factor from the model to the Parthenon is 2 to 100, or 1/50th. Or if we want to put that in words, we can say the, didn't actually write the model is 1/50th of the actual, which is what the question is actually asking for. Well, we can also say, how does the actual compare to the model, which is the same ratio, just flipped around, which is why we said the actual Parthenon is 50 times bigger. Again, every time we talked about scale factor, we talked about how there's 2 separate answers depending on which way you're looking at it, either from small to big or big to small. And as long as you can get the general idea of where this ratio comes from and how the two are related, be okay. All right. So number 6, architecture. Scale model of office building. The model's 9 inches tall. The actual office building planning will be 75 feet tall. So here's our two numbers. 9 inches, 75 feet. So if we just want the scale of the model, that's just the ratio. So it's 9 inches to the actual 75 feet. And that's it. That's all we're looking for. And then we can simplify this. 9 and 75, we can divide both those by 3. So this becomes 3 inches to 25. And if you really wanted to, you could divide this by 3 again and say 1 inch is 8 1/3 feet. But whatever, it's good enough. Okay. So notice here, we didn't have to convert units. All we want is the scale. Scale can have different units. Nobody cares. Okay, just the rate between model, the actual. Okay, but now we want scale factor. That's where we just want one fraction, no units. So we want to cancel units out. So we either need to convert inches to feet, feet to inches. And again, if we made 3 inches into feet, that would be a decimal or a fraction, and we probably don't want that. So let's convert feet to inches. So since there's 12 inches in 1 foot, say 25 times 12 is something, 300. So 300 inches, not spelled with an M. Okay. And then 3 inches is already in inches. So this is our same scale, but with the same units. So 3 inches on the model, 300 inches on the actual. And if we write that as a fraction, 3 inches over 300. And then we just simplify this. So the units are going to cancel out. And 3 divided by 300, or we can divide 3 and 300 by 3, and that gives us 100. So what is our scale that it used? Say the model is 1/100th of the building, the actual building. Or we could say the actual building is 100 times the size of the model. Okay? That's our answer. Either 1/100 or 100. 1/100 is the one the book wants. And let's box off. Then we get to the last one, which is causing us trouble because we had to think a little bit more. We didn't have this geography one. I got rid of this one. Let's get rid of it again. Hold on. Just take a second. Alright. Well, I have a that's okay. Alright, what are we doing? Craig's making a scale drawing of the White House on a piece of paper. A White House 168 feet by 150 feet wide. Choose an appropriate scale for the drawing. Use that scale to determine the drawing's dimension. Alright. So if we draw this out, it's a little hard to see. So here's our White House. It's a rectangle. And it's 168 feet by 152. And we want to shrink that so that it fits on a piece of paper, right? It's 11 inches by 8.5 inches. Okay. One thing you'll notice is that the White House, believe it or not, is not designed to be exactly proportional or exactly similar to a regular piece of paper. So it's not going to be perfect, and that's okay. Let's just look at the the ratios we can come up with. So if we take our long sides, say we have 11 inches to 168 feet. Okay. And if we divide that out, and I'm actually going to divide it the other way. I'm going to say, what's 168 divided by 11? And you get about 15.27. So we can say this is about every 1 inch to about 15 feet. Okay? This actually be 15.2727. Whatever. This doesn't have to be perfect. We're putting out a piece of paper for Craig. Who cares about Craig? Okay? Then our second rate, 8.5 to 152 feet. Let me do the same thing. What's our scale there? Undivided again. What's 150 divided by 8.5? You get about 17.88. So let's say 1 inch is about 18 feet. I'm going to use one of these two scales. Actually, let's try both these scales. Why not? Okay. So what if I want to do 1 inch for every 15 feet? How could I fit this on the paper? So let's say it's going to be test A. Trial A. So if I make this 11 inches, I want to go edge to edge. I would say 11 inches times, no, wait. Got that backwards. How do I want to do this? Let's see. So let's say 168, 11. That's how we want to get from one to the other. Okay. Let's try this again. Let's say 11 times 15 is about how much? It's 165 feet. So if I do 100, now wait, why am I? This is not so great. Now I'm confusing myself. Okay, so 1 over 1 inch is 15 feet, and I have 168 feet. Okay, so I want to do it the other way. I want to go 168, right? The actual length divided by 15. So if I do that, okay. Oh, let's keep my old cursor. That's messed me up. Okay, so 168. If I divide that by our scale of 15, we get 11.2 inches, right? And that's not gonna fit. It's because it has to be less than 11. So this 1 to 15 is not gonna work so well. So what if I do SB here? What if I use scale B? So 168 feet divided by 18. That gives me about 9.3 inches. That's not going to go all the way to the edge, but that's pretty close. And then if I do 152 feet divided by 8.5, or divided by 18, I get 8.4 repeating inches. So if I use, oops, sorry. So if I divide both these by our scale, 18 feet per inch, right? So I can take the actual dimensions and it'll shrink them down this 9.3 by 8.4. And could we fit a rectangle that's 9.3 by 8.4 in our picture? Yes, we can. A little bit smaller, right? Just close enough. Another way we could look at this, if you're like, where did these numbers come? Okay, so we know this is the scale we want. So if I made a proportion, if I said 1 inch for 18 feet, this model or the paper, the actual, and that's going to be equal to, we can pick any of our sides here. We put 168 on the bottom over x. And then if we solve this first, you notice it's 1 times 168 divided by 18, which is what we did here, 168 divided by 18. Okay, and then we could do similar proportion, 1 over 18 equals x over 152 for our other side. Okay. We could also make proportions using this 1 to 15 scale, but again, you would get side lengths that won't work. Like they'll be too big to fit on the paper. Okay? That's about it. All you need to do, scale models, write a ratio between the two, simplify if you can. If you want to get a scale factor from that, convert your units so that they have the same units on both sides, and then simplify that. Scale and scale factor. Alright, and then I'm going to attach a copy of the 7th grade notes here. Write some notes about scale and scale factor and remind yourself that you've done this once before. Okay, good night.